Hello everyone, my name is Rajan Sharma. In this video, we are going to discuss about MCP. So, what is MCP? What MCP server does? And how MCP client connect with it? How an AI application connect with MCP and use its tool, resources, and the prompt through the MCP system. So, by the end, I want to make that MCP simple by a host, a client, and a server, and capabilities exposed in a standard way. So let me show you the journey first. So we will start with why the MCP server exists, then we will understand the main participants of host, client, and server, and then after that we will look at the capabilities a server can expose, tool, resources, and prompts. Then we will go on the level deeper into the lifecycle, JSON-RPC messages, server code, client code, and how this connect with the AI model. So the goal is simple. After the video, MCP server should feel like a clear client-server architecture, not a mysterious AI tab. So let's begin with the basic problem. AI applications are useful when it's connect with the outside world and it able to interact with that. A model may need to read documents, it may need to create tickets, it may need to query a database, it may need to call a cloud API, it may need to trigger a workflow. The model itself does not magically know how to do all of it, but it needs to structured way to reach those systems. Now, so the basic problem is this. AI application need access to the tools, data, and the action outside of the models. Before MCP, every integration have its own connector. So one connector for the document, one connector for ticket, one connector for database, one connector for API, and one connector for workflows. And every connector bring its own behavior, like different authentication, different schemas, different input format, different output format, and different error handling. Now, this works for one or two system, but as soon as you start connecting many tools, it becomes hard to maintain. This repeated integration work is what I call the custom glue code. MCP gave us a clear pattern. So the AI application does not need to directly understand every external system. The AI application use the MCP client, and the MCP client talk to the MCP server, and the MCP server expose all the capabilities from the external system. So instead of many custom integration patterns, MCP give one standard protocol path. That is the heart of MCP, a standard way for AI application to reach external capabilities. Now look at the core architecture. There are three main participants. First, the host. The host is the AI application where the user experience live. The second is the MCP client. So the client is the protocol connection inside the host. Third is the MCP server. So the server expose capabilities. Those capabilities may be the tool, resource, or the prompt. Now, behind the server, there may be API, database, files, or the workflow. A simple way to remember this: host is the AI application, client is the connection, and server is the capability provider. So let us understand the host first. The host is where the user interacts with the AI application. It could be an IDE, it could be a desktop assistant, it can be an internal enterprise AI app, it could be an AI agent. The host manages the conversation, the model experience, and the connected MCP servers. So when you think about the host, think about the place where the AI products lives. So the user talk to the host and the host coordinate the rest. Inside the host, we have the MCP client. So the MCP client is the protocol connector. It know how to speak with the MCP server. it initialize the connection, it discover what server can provide, it send tool call, and it receive the result. Usually one client have one MCP server and one connection. So if the host connect to MCP server, it may have the 5 MCP client connections. The idea is simple. The client is the bridge from AI host to the MCP server. Now we come to the main topic, MCP host. So the MCP host is a program that exposes capabilities to MCP clients. It can expose tools that the AI can call. It can expose resources that the AI can read. It can expose prompt that the AI can understand. Very often the server wraps something real behind it. It can be the file, API, database, ticket system, or the workflow. So do not think of an MCP server as the model. It is not the LLM. Think of it as a capability provider for the AI application. Most MCP server exposed 3 kind of the capabilities. Number 1 is tool, number 2 is resources, and then number 3 is the prompts. So tool are executable actions, resources are readable context or the data, prompts are reusable templates or the instructions. So these are 3 building blocks are very important. Once you understand them, the rest of the MCP become much easier. So whenever you see an MCP server, ask what tool does it expose, what resources does it expose, and what prompt does it provide. So let's start with the tool. A tool is a capable function. The AI application can ask the MCP server to run it. For example, search logs for the service, create a ticket, query a database, or get weather for a location, run a calculation. A tool has a name, it has a description, and it has an input schema. Now that description and schema help the AI application understand when to call the tool and what argument to provide. The simple definition is this: tools are actions the AI can request through the MCP servers. Resources are different from tools. So a resource is usually something AI application can read. It may be a file, it may be a document, it may be a database schema, it may be the API response, it may be a knowledge base article, it may be a configuration record. Resources are about context. So they help the AI application understand the environment before answering or taking an action. So the simple definition is resources provides readable context to the AI application. Prompts are the third capability. A prompt is reusable instruction template. For example, an incident analysis prompt, a code review prompt, a SQL troubleshooting prompt, a deployment review prompt, a support response prompt. So instead of rewriting the same instruction again and again, a server can expose a prompt as a reusable workflow. Prompts are usually the key package are repeatable workflows or repeatable patterns. So remember, tools perform action, resources provide context, and prompts guide the repeatable. Now the next question is how the MCP client know what the server can do. So it discover capabilities. The client can ask the list of tools, it can ask for list of resources, and it can ask for the prompts. The server returns metadata including the name, descriptions, and input schemas and other details. This discovery step is important because the AI application need to know what is available before it can use anything. So discovery is like asking the server, tell me what capabilities you provide. So let us zoom out and look at the pattern and the life cycle. So The flow is simple: initialize, discover, call, return, close. First, the client and the server initialize the connection. The client discover capabilities. The client call a tool for a resource. The server return the result, and finally the connection can be closed. This life cycle gives MCP a clear structure before actual work begins. Here we see an initialize message. So don't worry about every field. Focus on the idea. So the client is saying, I want to start an MCP conversation. Here is the protocol version I support. Here is my client information, and here is my capabilities. The server can respond with own information and support capabilities. This step prepares both sides for rest of the conversation. It is like a handshake before doing a real work. So after initialization, the client can ask, what tool do you provide? This is what tool list does. So the server respond with tool definitions. Each tool have a name, a description, and the input schemas. For example, the server may return a tool called get service health. The description say it checks service status, and the input schema tells the client what argument we are expecting. So this is how the AI application gets structured knowledge of what server can do. So once client know the tools, it can call one tool. Here the method of the calls. So the client provide the tool name and structured argument. For example, call get service health with service name set to the payments. The server receive the request, find the matching tool handler, execute it, and return the result. This is the core execution of the MCP, and this is called discover the tool, call the tool, or and receive the result. MCP server use a structured request and response style based on the JSON-RPC. A request has a method, parameter, and an ID. So the method tell the server what operation is being requested. The parameters carry the structured input. The ID helps connect the response back to the request, and this is useful because it gives MCP a consistent message format. So even when different server expose different capabilities, the protocol conversation still has a common shape. Now let's use a simple example. User asks question, how is the payment service? The AI application look at the available tools, and it see a tool called get service health. The AI choose that tool. The MCP client call the MCP server. The server read the monitoring data, and then it returns the result, status health, latency, which is 120 milliseconds. The example is simple, but it shows the complete idea. Use intent become a structured tool call. Now let's look at the server code. We create a MCP server object. In this example, the server is called incident server. So then we register function as tool. One tool check the server health, another tool create an incident ticket. At the end, we run the server so MCP client can connect to it. The key idea is this: the server expose capabilities. It's not the AI model. It is the program that make external capability available to the AI application. Here we have a simple read style tool. The function name is get service health. It takes one input, service name. Inside the function, we return structured data about the service. For payment, the status is healthy and latency is 120 milliseconds. For orders, the status is degraded and latency is higher. So for the MCP point of view, the function is now a tool. The AI application can call it and use the written data in its answer. The second tool is action style. So it creates an incident ticket object. The input argument are service name, severity, and the summary. The functions return a structured response with the ticket ID, service, severity, summary, and the status. So again, the MCP server point of view, this is just another tool. So the server the server receive structured arguments, run the tool handler, and return the structured output. Now let us look at the client side. The client defines server parameters. In the example, it start a Python file called incident server py. Then it opens sorry. Then it opens read and write stream using Studio. After that, it creates a client session. So the session is important because it wraps the protocol conversation between client and the server. Then the client call initialize. So the client is now ready to discover capabilities and call tools. So after initializations, the client lists all the available tools. The server responds with the tool metadata. In this example, the output showed two tools, get service health and create incident ticket. So this is the moment where the AI application learns what actions are available through the server. Without discovery, the AI application would not know what MCP server can provide. So now client call one tool, it call get service health and passes service name as payments. The MCP server runs the matching tool handler. The result comes back with the status healthy and the latency 120 milliseconds. The important point in this, the client does not need to know how the backend monitoring system works. It only need to call the MCP tool in the structured way. Now let us connect this with an AI model. So the MCP server expose tools, the MCP client discover those tools. The AI application converts that tool metadata into the tool calling format that is the model understands. And then the model can reason over the user request and decide which tool is relevant. MCP does not replace the model. MCP gives the AI application a standard way to expose external tools to the model. Okay, this is the full flow. The user asks a question, the model reasons over the request, the model select a tool, and then MCP client send the tool call. The MCP server exposes the capability and the result returns. Then the AI application give the final answer to the user. So the model decide what should be done and MCP provides the protocol path for doing it. Now let's talk about the communication. So for local MCP, Studio is common. That means the host launches or connect to the local server process and communicate through standard input and standard output. This is very useful for the local development and desktop style integrations. It is simple, it has an overhead, and the host can directly manage the local processes. So Studio is often the local process communication path. And for remote MCP, the HTTP transport is used for the network-based servers. In this model, the server runs as a service. So the host or the AI application communicate with it over the network.
It's 12 o'clock.
So the host or AI application communicates with it over the network. And the transport changes, but the core MCP concept remains the same. You still initialize, you still discover, and you still call. You still receive results. So remember, transport may change, but the protocol model remain consistent. So one host can connect to many MCP servers. For example, one server for GitHub, one server for code base, one server for file, and one server for monitoring. So the host maintains dedicated MCP clients connection for those servers. This is powerful because each server can focus on one capability area. The host then brings these capabilities together inside the AI experience. So now look at the common use cases. For developer, MCP server can expose repositories, issues, pull requests, and the code tools. For data teams, that can expose a database, analytics, BI system, and for the operation systems or the operation teams, that can expose logs, it can expose the metrics, incidents, and the service health. For the knowledge assistants, they can expose document, files, knowledge bases. And for the business workflow, that can be exposed CRM, the system, tickets, approvals, and the automation. So the patterns stays the same. Expose a capability through an MCP server so the AI application can use it. So now let's recap a mental model. So host equals AI application, client equals protocol connections, server equals the capability provider, tools are actions, and resources are context. Prompts are templates, and this is the simplest way to remember the MCP. MCP is the standard bridge between AI application and the external systems. So let me close with the main idea. An MCP server is capability bridge between AI applications. It exposes tool, resources, and prompts so the AI application can reach external system in a standard way. So MCP does not replace APIs. MCP does not replace models. It standardizes how AI application connect to the capabilities. Once you understand that, the whole architecture becomes much simpler. So host, client, server, capabilities, external system. That is the foundation of MCP. Thank you everyone.